as you may be getting sick of hearing me say, patterns. That's about trying to find patterns. That's the same with our curves. If I can find symmetry, then really I only have to graph half of the picture, because then I can use symmetry and reflect it or rotate it or whatever that symmetry happens to be. So there's two very special types of functions. There are odd functions. The formal definition for an odd function, function negative x is equal to the negative of function x. So if you had to prove something was an odd function, that's what you have to prove. Function negative x is equal to negative function x. Visually, we're talking about something that has point, or some people call it rotational, symmetry about the origin. So if you could spin that curve 180 degrees, you get the same picture. Let's have a look over there at our four. We've got our parabola, our hyperbola, our cubic, and our circle. Any of those an odd function? Okay, did someone say cubic, did I hear? Yeah. Rotate that 180 degrees, I'll get the same picture. Any others? Which one, sorry? Yeah, hyperbola. Again, if you imagine rotating that 180 degrees, we'll get the same picture. Is that all?
Circle?
Circle? No. Why not? Well, we'll come back to it. We'll see the definition for even functions and we'll come back to it. Spins 180 degrees, looks the same. So yes, y equals x cubed is a very basic one. 1 on x, we saw that, the hyperbola. In fact, any polynomial where all the powers are odd, strangely enough, turns out to be an odd function. That's not a proof, unfortunately, but if they haven't asked me to prove it, and I notice, hey look, all the powers are odd, well I know it's an odd function. And so yeah, there you go, minus 3x to the 9 plus 2x to the 7, whatever that happens to look like, that would be an odd function. In fact, all odd functions that are continuous must go through the origin because of the rotational symmetry. Now the hyperbola doesn't because it's not continuous. But anyone that's continuous must go through the origin. So if you know a function's odd, straight away you know one point that's on the curve, 0, 0.
What do you mean by continuous?
It means there's no breaks in it. So it just continues all along.
So like a tan graph wouldn't be continuous?
Tan graph is not continuous, that's right. Hyperbola is not continuous because it doesn't exist at x equals 0. Anything that's got a break in the curve is not continuous. Or, I suppose more correctly, is discontinuous, I think is the correct term. Okay, we're going to prove that x cubed plus x to the 7 is odd. As I say, just looking at it and going, oh look, all the powers are odd, that's not good enough. We have to prove this. Function negative x is equal to negative function x. So function x is x cubed plus x to the 7. Function negative x, wherever we see an x, replace it with a negative x. Okay, negative x cubed, negative x times negative x times negative x would leave me with negative x cubed. And negative x to the power of 7, negative x times negative x times negative times negative times negative, also it becomes negative, so we get minus x to the 7. But I could factorise the negative, and there I have it, because inside the parentheses is function x. And so function negative x equals negative function x. So yes, that is an odd function. Okay, even functions. In this case, function negative x equals function x. This one has symmetry, but it's a line symmetry, or has an axis of symmetry, which is the y-axis. So again, let's have a look over to our 4 graphs there. Which ones? Parabola definitely has line symmetry. So yes, you could fold the parabola on top of itself. So that is an even function. Any others?
Circle.
It comes back to the circle again. And again I say no. And now I'll come back to why. Because we're talking about odd or even. What was that second word again?
Function.
What was the definition of a function? It's not a function. Circle's not a function, so it can't be an odd or an even function. Got to be a function first. All right, so yes, x squared. X squared plus 4. Minus 3x to the 6 plus 2x4 minus 27x squared. This time you notice, well, if we accept that 0 is an even number, then all the powers are even, because that 4 in the second example there, we could write as 4x to the power of 0. So if you notice all the powers are even, then that would be, I suppose, an easier way to explain this 1x squared plus 4. All the plus 4 is doing is shifting the curve up. So it's not going to change the axis of symmetry. Let's prove the evenness of x squared plus 4, just in case you don't believe me. So there's our function, x squared plus 4. Function negative x. So negative x squared, negative times negative is a positive. X squared plus 4, sure enough, that's function x. So yes, satisfies our condition for an even function. Okay, that'll do us.